Next chapter, area of polygons. Area of a parallelogram. A parallelogram is a quadrilateral in which each pair of opposite sides is parallel. That also means the opposite sides are equal. The area of a shape is a measurement of the region bounded by a closed plane, or in other words, the area within the lines of a shape. This is a parallelogram ABCD. Based on our definition, AB and DC are parallel. We also know that AD and BC are parallel. Another feature of a parallelogram is that adjacent angles are supplementary or add up to 180 degrees. So angles ADC and BCD are supplementary. The area of a parallelogram is given by the formula area is equal to base times height. The base of a parallelogram is typically the longer pair of sides of the quadrilateral. So for this parallelogram, the base is 10 centimeters, but 5 centimeters is not the height. One thing to remember is that the height of a parallelogram must be perpendicular to the base. The height is the distance between the parallel lines and can be placed anywhere inside or outside the figure as long as it's perpendicular to the base. In this parallelogram, the height is 4 centimeters, so the area is 10 times 4, which gives us 40 square centimeters. Let me help you visualize why the area of a parallelogram is given by base times height. When I placed the perpendicular height here, I created a triangle, the blue region. And because this angle and this angle are supplementary, I will lift the triangle and connect it to the other side here. Now we have formed a rectangle ABCD with a height of 4 centimeters, a length of 10 centimeters, and therefore an area of 40 square centimeters. So when we use the formula for a parallelogram, we are actually calculating the area as though the parallelogram were a rectangle. Finding the area of a parallelogram using trigonometric ratios. Now, sometimes the perpendicular height of a parallelogram is not given. In such cases, we apply the trigonometric ratios. Now, in this figure, the diagonal BD divides the parallelogram ABCD such that triangle ABD is equal to triangle BCD. Both triangles have the same area since angle BAD and angle BCD are equal. Therefore, the area of triangle ABD is equal to the area of triangle BCD. Therefore, we can use the formula area is equal to a half AB sine A. And therefore, the area of ABCD is equal to 2 times the area of triangle ABD. That is equal to 2 times a half AB sine A, and that gives us AB sine A. Giving specific measurements to our parallelogram, suppose we have a parallelogram with sides 10 centimeters and 8 centimeters, and then we have an angle here of 70 degrees. Area is equal to AD times AB times sine A, and that is equal to 8 times 10 times sine 70. Sine 70 is equal to 0.9397. So 8 times 10 times 0.9397 gives us 75.18. So the area of the parallelogram is equal to 75.18 square centimeters. Next, area of a trapezium. A trapezium has only one pair of parallel sides. If the parallel sides measure A and B respectively, and the perpendicular distance between them is h, then its area is given by the formula area is equal to a half into A plus B times height. And so, working with the real measurements, suppose A in this case is 6 centimeters and B is 10 centimeters, h is 5 centimeters, we can calculate the area of this trapezium. Area is equal to a half into 6 plus 10 times 5. That gives us a half times 16 times 5, and that gives us 40 square centimeters. Suppose we have this kind of a trapezium. We do not know the perpendicular height, but we can find it. If you drop a perpendicular here, the distance TS is equal to 9 minus 6, that is 3 centimeters. The perpendicular height has completed a right-angled triangle. Using Pythagoras' theorem, h squared is equal to 5 squared minus 3 squared. H squared is equal to 16 and h is equal to 4 centimeters. And so the area is given by a half into 6 plus 9 times 4 by 2 1 by 2 2. 15 times 2 is 30, and so the area of this trapezium is 30 square centimeters. Now, most polygons, including some of the irregular quadrilaterals, do not have specific formulae of finding their areas. Their areas are, however, found by dividing the shapes into familiar figures and then summing up the respective areas.
And so the biggest challenge is not falling behind, and the strategy is do whatever needs to be done so you don't fall behind. Seek help wherever you can find it, from students, from student help centers, from the teacher, from the teaching assistant, wherever you can get it. Because if you fall behind, it's like you're missing a floor in the building, you're missing a brick in the wall, and you just can't build the second floor without a good understanding of the first floor. It applies course to course, it applies class to class. Miss a class, one class, maybe that's fine. Miss 2 or 3 for whatever reason, the rest of they're speaking a foreign language for you, and you just have to make it up, or going to class has no point. If you don't go to class, it just gets worse. It snowballs, and once it starts going downhill, you're in trouble.